Hello everyone. Today I am going to start motion. Already I have started motion. In that I am going to start uniform motion and non-uniform motion. Motion. We have two types of motion. So in this we are discussing motions of non-living objects, not living objects. How Jarvis sir runs in. We are not talking about the motion of Jarvis sir or living object. We are talking about motions of non-living objects. For example, car, train, aeroplane, bus, all these non-living objects. Whether they move with uniform motion or non-uniform motion, that we will discuss in today's class. Motion we know very well. If an object is moving from one point to another point, with respect to its origin and time, we call it as motion, isn't it? Further to that, we will discuss what are uniform motion and non-uniform. Uniform motion. What is uniform motion? First of all, we'll discuss. Another is non-uniform. Non-uniform motion. So, uniform motion, non-uniform motion. We know very well, motion and respect, both these physical quantities are relative motion, because motion is not absolute, rather it is relative. I have explained you what is relative motion. What is relative motion? If object is at rest, then the other thing will appear in motion. If that is at rest, this thing will appear in motion. So in this, both object and rest are relative motion. What does it mean? One of these object has to be at rest, then other will appear in motion. If the other object is at rest, this will appear in motion. If both should not be at rest, both should not be in motion. That is not relative motion. What is relative motion? In relative motion, one has to be at rest, then other object appears to be in motion. If that other object is at rest, this object will appear in motion. That's why rest and motion are relative to each other. So, motion you know very well. Now we will discuss what is a uniform motion and what is non-uniform motion. Now, this we are experiencing in our daily life every day. If I explain it just now, you will understand. Yeah, this is called uniform motion. You will understand. What is uniform motion? An object is said to be in uniform motion if it covers equal distance in equal interval of time. So, whenever we are talking about motion, what we are describing motion. While we are describing motion, what we are describing? We are covering distance or displacement. Isn't it? So here, if an object cover equal distance in equal interval of time, then such type of motion are said to be uniform motion. A bus, a train, an aeroplane, a cycle, if it is covering equal distance in equal interval of time, then you call it as uniform motion. The object is moving in uniform motion. The bus is traveling with uniform motion. It travels a distance of these with uniform speed or velocity. So here first we are trying to know what is uniform motion and non-uniform motion. We will discuss the characteristics also. So uniform motion, as simple as that. If an object covers equal distance in equal interval of time, then that object is said to be moving with uniform motion. For example, you take the data children. Okay, this is what it is. Serial number. Okay, then distance D measured in meter, time seconds. Okay, now children. So firstly, in 1 second, the object cover a distance of 5 meter. In 2 seconds, the object cover a distance of 10 meter. In 3 seconds, an object cover a distance of 15 meter. In 4 seconds, an object cover a distance of 20 meter. In 5 seconds, the object cover a distance of 25 meter. So in every second, the object is covering a distance of 5 meter. So if an object cover equal distance in equal interval of time, 1 second, 5 meter. 2 seconds, 10 meter. Is it covering 5 meter or not? We see. 2 minus 1, again 1 second. 10 minus 5, you get 5 meter. Okay, in 3 seconds, 3 minus 2, again you are getting 1 second. In 1 second, 15 minus 10, 5 meter. So in this case, the object is covering equal distance in equal interval of time. Such type of motion are called uniform motion. If an object covers equal distance in equal interval of time, it is known as uniform motion. Okay, children. Now, you know very well what is uniform motion. An object said to be moving in uniform motion if it covers equal distance in equal interval of time. What are the examples you want to know? You know, what are the examples of uniform motion? An aeroplane moving in the sky at a speed of 800 kilometer. It is not taking off or landing. It is moving in the sky, and then it's maintaining a speed of 800 km per hour or 500 km per hour. That is uniform motion. A bus moving on a highway at a speed of 60 km per hour. A car is moving on a highway at a speed of 40 km per hour. A train moving at a speed of 60 km per hour or 40 km per hour. That is uniform motion. Uniform motion, object covers equal distance in equal interval of time. Covering equal distance, 5 meter in 1 second. Next 5 meter. Again, next 2 seconds, 10 meter. 10 meter means in 1 second. 10 minus 5, 5 meter. So it covers equal distance in equal interval of time. This is possible for all the objects which are moving on the road or train or aeroplane, whatever. Not, only when a train is moving, not reaching the platform or leaving the platform. It is after leaving the platform, it maintains uniform motion. A bus or a car cannot maintain a uniform motion, in the town. When it leaves the town, it goes on the highway, then it maintains a speed of 70 kilometers per hour or 60 kilometers per hour. That is, uniform motions are maintained not in the crowded place, not in the town. An aeroplane, while landing, it cannot maintain a uniform motion. While taking off, it cannot maintain a uniform motion. Where it can maintain a uniform motion? When it is moving in the sky. To maintain a uniform motion. Okay, now, so these are the examples of uniform motion. An object covering equal distance in equal interval of time, you call it as uniform motion. There are so many examples in a very daily life from where we can write so many examples of uniform motion. A bus traveling on the highway at a speed of 60 km is a uniform motion. Because there you have a chance to move with uniform, covering equal distance in equal interval of time. Not in town, crowded place, you cannot maintain same speed or velocity. Since it cannot cover same distance in same interval of time. So it is possible only on the highways. A train moving at a speed of 80 kilometers, aeroplane moving at a speed of 800 kilometers per hour, a bus moving on the highway at a speed of 60 kilometers per hour are the examples of electric charge, electric current, or the speed of light traveling at a speed of 300,000 kilometers per second is also an example of uniform motion. Light coming from sun reaches the surface of the earth, travel at a speed of 300,000 kilometers per second or 3 into 10 power 8 meter per second. That is also an example of uniform motion. Simple as that. If an object covers equal distance in equal interval of time, then the object is said to have uniform motion. So we have a data here. Using this data, we can plot a graph. When we can plot a graph, to what quantities we can plot a graph? Vector quantities. The quantities which has both the magnitude and direction. Such quantities can be plotted on the graph. So, uniform motion. Here we have distance, one physical quantity, time is another physical quantity. So we can plot it on a graph. So time is do not depends on distance. Distance depend on time. That's why if you plot a graph on x-axis, this is x-axis, this is y-axis, zero origin. Okay, x-axis, and this is y-axis. So on x-axis we take time. Time is measured in seconds. Okay, Rajana? And then distance we take it on. Distance is measured in meter. We take it on y-axis. So we can plot a graph by taking this data in 1 second. 1 second. You know, I can write time here. Okay. Okay, time second. In 1 second. 2 second, 3 second, 4 second, 5 second, for example. It is covering equal distance. 5 meter, 10 meter, 15 meter, 20 meter and 25 meter. Like this, you can plot a graph between distance and time. Distance is taken on y-axis because it is dependent physical quantity, whereas time is taken on x-axis because it is independent physical quantity. The time does not depend on this distance. Travel depends on time. I travel a distance of 5 meter in 1 second. That's why we take time on x-axis, distance on y-axis. So here we are plotting, a graph between distance versus time. Now, uniform motion. If an object is covering equal distance in equal interval of time, this is known as uniform motion. So we can plot a graph by taking this distance and time. While describing uniform motion, what we are coming across? Distance and time, two physical quantities. So surely we can plot a graph. Then we will see in distance time graph, if an object is covering equal distance in equal interval of time, what type of graph do we get? Shall we try to plot? No. 1 second, 5 meter. You know very well, you must have learned in 8th class. Now, in 2 seconds, it covers a distance of 10 seconds. In 3, it covers a distance of 15 seconds. In 4 seconds, it covers a distance of 20 meter. In 5 seconds, it covers a distance of 25 meter. So it is covering equal distance in equal interval of time. Let us join these dots. Now you get what type of graph? You get a straight line graph in uniform motion. What does linear graph represent? What does straight line graph represent? It represents uniform motion. Whenever you get a straight line graph, what does it represent? It represents the object is traveling with uniform speed. What does it mean? It is covering equal distance in equal interval of time. Then only when we plot a graph between distance and time, what type of graph we get? This is called slope of the graph. What is this? This is called slope of the graph. What does it represent? Slope of the graph represent what type of motion it is. If we get a straight line graph, then what does it represent? It represents the motions are uniform. What do you mean by uniform? Covering equal distance in equal interval of time. So here distance and time are directly proportional to each other. What does it mean? Directly proportional. Distance and time are directly proportional. Means what? Means if time increases, distance increases. If time decreases, distance decreases. So here 1 second, 5 meter. 2 seconds, 10 meter. So time is increasing, distance also increasing equally. That is the meaning of direct proportionality. So here you get the slope of the graph is straight line. It represents what? Uniform motion. In a graph, distance versus time, if you get a straight line graph, slope of the graph is straight line, what comes to your mind? What is your understanding? What you understand about that? The motions are uniform. The bus is traveling with uniform motion. The train is traveling, whatever it may be. But what represents what? Ultimately you get uniform motion. Okay, children, I hope you understood this. Now we will move to the next topic in this, that is characteristics of uniform motion. Characteristics. What are the characteristics of uniform motion? Characteristics of uniform motion. Characteristics of uniform motion. In this first property, children, whenever we write characteristics, first of all we have to write the definition of uniform motion. What is it? If an object covers equal distance in equal interval of time, then that is called, it is known as uniform motion. First you have to write the definition of uniform motion. So here we are writing characteristics of uniform motion. If an object covers equal distance in equal interval of time, then the object is said to be uniform motion. Second property, the definition you have to write, definition. Second characteristics, if you plot a graph between distance and time, what type of graph we got? We got a straight line graph. That is the second point. If you plot a graph between distance and time, we get a straight line graph. That is the second characteristics of uniform motion. In uniform motion, what type of graph we get? Straight line graph. Graph plotted between distance and time is a straight line. It represents both are directly proportional to each other. So we get what? Straight line graph. When plotted between distance and time, what we get? Straight line graph. Third characteristics of uniform motion. That is, uniform motions are non-accelerated. Non-accelerated motion. Non-accelerated motion. Children, you want to know what is accelerated motion? Non-accelerated motion means change in speed. Speed 1 meter, in 1 second 5 meter, in 2 seconds 15 meter, in 3 seconds 45 meter, in 4 seconds 75 meter. So speed is changing. That is called acceleration. Starting, yes, you are moving, running, increasing speed. That is acceleration. Now, that is standing on at one point and just moving my feet up and down. That is speed is not changing. Velocity is not changing. So, motions are not accelerated. Accelerate means increasing. Increasing speed is called acceleration. If you are not increasing speed, non-accelerated. Yes, I am doing like this. You do sometimes stand at one point and then you move your feet up and down like this. This is non-accelerated. No change in speed. Constant speed is non-accelerated. In uniform motion, 1 second 5 meter, 2 second 10 meter, 3 second 15 meter. So in every 1 second only increase in only 5 meter. Speed is constant. Is it increasing? Is it decreasing? No. 1 second 5 meter, 2 second 10. 10 means 2 minus 1 1. 10 minus 5 again 5 meter. Every second 5 meter only. Constant. No change in the speed. That's why uniform motions are non-accelerated. Why we are saying non-accelerated? There is no change in the speed. So these are the three characteristics of uniform motion. First, whenever you write characteristic, first one is definition. If an object covers equal distance in equal interval of time, the object is said to have uniform motion. Second, we plot a graph between distance and time. In uniform motion, we get a straight line graph. Third, non-accelerated. Uniform motions are non-accelerated because there is no change in the speed of the object. Constant speed, uniform speed. That's why motions are uniform motion. These are the three characteristics of uniform motion. In my next video, I am going to explain you non-uniform motion. Thank you very much for watching this video. Please, 9CA, CB, CC children, watch this video carefully. Try to understand the concept. If you're not following, please ask question. Do not simply sit on your doubt. Some person, whenever we ask you to do something, okay sir, okay, right, okay sir, okay sir, okay sir, we don't give any feedback. no respond. Sir, I got it, sir. I did not get this, sir. Please do that. Please do that. Thank you very much.